When it comes to weather-related hazards, a lot of attention goes to tornadoes and hurricanes, and for good reason. And I think increasingly the same is true for lightning and heat. But one weather hazard, in my opinion, still doesn't get nearly the respect it deserves, one that made tragic news last week in rain-soaked Texas. Now here's a breakdown of weather-related fatalities by hazard. 5 are shown here. The blue bar is the annual average over the last 10 years. The maroon bar is just for 2015. Now, lightning fatalities have really come down in recent years. The average is about 30 per year. There have been very few landfalling tropical systems in the last decade, so hurricane fatalities are down too. The tornado and heat-related fatality number is still above 100 per year on average, but last year was quiet for both. Now, the flooding 10-year average is around 80, which is about the same as the 30-year average. And last year it was 155, suggesting this problem isn't improving. And when you break down the flood fatality numbers over the last 10 years by situation, you find more than half occur in vehicles, usually people trying to cross flooded roadways. Now here's a simple but realistic way to think about a vehicle in water. A car's weight creates friction with the ground at the tires and basically holds the car in place. When water enters the picture, the surface becomes slippery, reducing that frictional force. And water also introduces buoyancy that acts upward on the vehicle. Archimedes first told us this force equals the weight of the fluid displaced by the object. And water weighs about 62 pounds per cubic foot. And cars displace a lot of water. Once some of the vehicle is submerged, the weight of the car is essentially reduced by the weight of the water displaced by the car. Now, as an example, let's assume a 3,000-pound car and say water rises just 6 inches up the body. Now, a typical car is maybe 5.5 feet wide and 14 feet long, and we'll do the math for you. That's enough volume of car to displace 2,400 pounds of water. So the car's net weight drops to just 600 pounds in this situation. And I didn't even take into account water displaced by the tires. Now, if the water is moving, there's a sideways force on the car that's actually proportional to the speed of the moving water squared. So you double the speed, that force goes up by a factor of 4. And when that lateral force exceeds the weight of the vehicle, the car floats away. And I didn't even consider here the fact that water reduces the frictional force, which makes this net weight even less. No wonder the National Weather Service aggressively warns not to underestimate the power of moving water. 6 inches can knock over an adult. 12 inches of fast-moving water can carry away a small car, while 18 to 24 inches can carry away most SUVs and vans. Indeed, in my opinion, the campaign slogan, "Turn around, don't drown," can't be repeated enough. The extended forecast is next.